Okay, now I'm recording. So, Salam, I went here on this, over here, this button, a split pane top button, okay? And then I added geometry spreadsheet. Then later I will tell you what it is. And I closed the scene view that was here already, okay? You got it now? And from the top bar now here, scene view we want, animation editor we don't want, render view we want, the rest of them we don't want. Geometry spreadsheet we already had it. So on top I only have scene view and render view. Okay? You did it. Now let's go to the right part. Close all of these top ones. We don't need any of them. And that's it. You don't have to do anything else. Okay? Now let's go here. And then let's go to a save current desktop as. So I'm going to the build option over here. Save current desktop as, and then maybe just name it eyesight. Okay, and then save it. So whenever you open your program, you can go from build to this interface over here. All right, cool. So now let's talk a bit. Let's bring down. Okay, okay, next thing. Let's go to this. We will see this icon over here, CH. From here, go to the OBJ. Okay. Now here is the canvas we're gonna work with. Here is the scene view, and here's the geometry spreadsheet that I'm gonna tell you. So this is the network that we drop all the nodes to tweak the attributes of the geometry. So in Grasshopper, when you want to add another node, you will double click. In Houdini, you will press tab. Okay. So you press tab here and then just type geometry. Okay. Then I will click once more. I'll go through it, and this is the first geo. Now everything will be inside this geo. So I'm not gonna continue having another nodes after this. I'm gonna double click and go inside it. Okay. And now you will see the addresses like OBJ, and then we have geo over here. Okay. So let's press tab again and bring a torus. Okay, this is just a test geometry that we're going to use. Okay. So in this torus, when you have these nodes, we want to see the parameters of these nodes. Okay, so we press P, and we always have this. If you press P on the keyboard, you always have these parameters that we're going to work with later. You might say, okay, maybe your background is not black. If you want to change it, let me just close this. If you want to change it, from this bar, you will go down towards the end. You'll see this eye color, and then you will go to the background, and then you change it to dark if you want. If not, it's not important at all. Okay, guys. So let's talk about how geometry works in Houdini. So you will see the parameters over here. I can change the number of rows and columns like other softwares. But the most important thing, so let's go to the geometry spreadsheet over here. And you'll see 4 classes of geometry. So first is points, the next is vertices, primitives, and the detail. What are those? So points are the points that we have. If you kind of click on this, these are the points that we have on our geometries, okay? And here in the geometry spreadsheet, these are the attributes that we are having on our points. So we have, in this case, we have the position. So P stands for position in Houdini, okay? So PE, PY, and PZ are telling us what are the positions of these points. So a point in Houdini is a vector, of course, from the 0, 0, 0, right? So in this case, these are the values of our first point, okay? The next one is the vertices. The vertices are the, like, imagine when you're working with Grasshopper, you will have this mesh face, mesh vertices, and that's it, right? But in Houdini, we have vertices and then we have also points. So it doesn't mean that these are, sometimes these are not shared between these two, okay? So any one of these points are individual for all of these primitives. So what is primitive? Primitive is basically the mesh face, okay? But sometimes you don't have the mesh face, it's only a line. So what is between 2 points is called primitive, okay? And the detail attributes are applied on everything. So I will say, tell it once more. The points, and we have all the attributes inside it. And then we have the vertices that we're not going to use a lot, actually. We have the primitives and the attributes inside it. There is no attribute here. Of course, you don't see anything. And then we have detail. And if we have any attributes here,
এর মতোই হবে আপনার
okay. Oh, you rented me. And then if you have detail, it means that you have the attributes applied on all of it. Okay. So let's work a bit. Let's see how it works. Let's drop down a color. Okay. So I just type color.
Maybe you can do the.
Yeah. Or Sina, you can maybe. Sina, you can mute like this.
I think I was mute, but there is someone who is not mute, and then this is disruption.
Will has if you can see. Ah, yeah. Okay. Cool.
Thank you.
Cool. Thank you.
How did you drop the color again, please?
Just tap and then type color. So if you press tab over here in this geometry, you will see all of them are different. So if I go back and press tab, you will see these nodes are different. Okay, these are for this object canvas that you're working. After we go in here and press tab, you will see all of them are different. And these are the ones that we're gonna tweak the attributes of the geometry with, okay, and change the behavior of the geometry. So one of the simplest ones is just color, okay? You type color, and then you have the parameters of the color over here. Cool. So, okay, let's see. If I connect these together and then press, let's talk about this also. Let me just make this red. So in order to render and display something in Houdini, you will have 4 options, 4 buttons, let's say. So the most important one is the display render. So if you go for the blue one, you will always display it. In this one, you will bypass it. So here it's not working anymore, but the next node will work. Okay, let me just drop down a very simple one that I'll tell you how to do it later. So, okay, I'm gonna say I want them as wireframe with this value. Okay, so I'm just gonna show you. So if this one is not bypassed, you will see it's red, okay? But if I bypass it over here, it's not working anymore. So it's not like Grasshopper that if you disable something, it won't bypass the rest. Here we will see if you bypass it, it's working like a relay. It passes the data through it, okay? So you don't have to delete everything every time. But in case you wanted to delete this, there are 2 options. You can just move it like this. Crazy, huh? So you just move it. It's crazy, like it's really crazy. Or the other crazy option is to also, if you want to cut this wire, you just press Y. So it's the scissor, and then boom. Okay, that's also crazy. And then you can also not crazily press delete. Yeah, that's not cool. Okay, so let's talk about the geometry spreadsheet a bit more. So let's see what the other one that is the pink one. That if you want to just shade it a bit, I mean in the color you won't see it. I will tell you later more about this pink one. So okay, let's just delete this for now. So guys, you see, I added a color. It didn't have color before, okay? And when I added a color, you will see this new vector. So colors are also vectors in Houdini. So you will see now the CDR means the color red is 1 in all of them. And the CD green and CD blue is 0, right? But why is that? Because we are applying this color node on the point class. So if I change this to primitive, you will see there's nothing here anymore. So if you go back to the primitive class, it's here. So we change the class of the color, the data, to the primitive class, okay? So if I go from the color type, if I go to the random color, if it's on primitive, you will see this type of colorful mesh faces in this case, right? But if I go to the point, you will see now it's working on points. So each point has colors and it's blending towards the adjacent a neighbor, let's say, points. Okay? You see how it's working? Every time in Houdini, we have to make sure that this attribute that we're adding is on point or primitive all the time. Sometimes we have to also use the detail. Okay. So now you have an overview of what's going on in Houdini. Any questions so far?
Yes, please. So the taskbar, or where you were controlling the colors, is not showing in my Houdini. So where do I get that?
You have to press P.
P. Okay, sorry.
Yeah. And whenever you press P, like it's always here for the rest of the notes also. So you don't have to press it twice. Okay, so if I just don't want to see it, but we always want to see it. Sometimes I also split this pane to 2 halves and I always have the parameters, but sometimes you don't want to see it, so I prefer to press P. Okay, the next thing that is really important in Houdini is how to group items, okay? How to select things, like in Grasshopper, you use list items or groups to select some sort of data within a list. In here, we use group also. So let's just drop down a group node and connect it to here. When I press over here, you will see everything is selected. Let's go back here to the, exam points, okay. So when I click, you will see everything is connected. I'm gonna go to the group type point first of all, because I want to select some points. And then I want to say, okay, like in Grasshopper, list item 2 or 3. I want to just select the number 2 or 3 or any other numbers. So you want to see the numbers. In Houdini, we can see the numbers on each point. All you have to do is to, from this far, scroll down, and you will see this note here, display point numbers. If I click on that, you will see the numbers, okay? In this case, let's say I want to select 980 and then space 807, okay? So now you will see we only selected these two, and that's how we manually select. You can also just close this. That's how we manually select something. But there are some other options that I will show you later. But let's say we're gonna use an expression this time. So this time let's create a group expression. Okay? And then we always start from the left when you have this, when you see these 4 dots over here. Sometimes you will see these requirements that you can just hover and see what it needs. Sometimes it doesn't show you. So we will start from the left, okay? So let's see what it gives us. First of all, I want to go back to points.
Adib, can I tell one thing? So one other option to bring components is also right click on a canvas, because some computers, I know that.
Oh, okay, we're not top. Yeah, yeah.
So if you right click, that's also a good option.
True. Yeah, if you don't have tab, you just right click, or if you prefer, it doesn't matter. So okay, let's drop down a group expression, and you will see here a vex expression, or like it's vexpression actually. Yeah. So we have to know what is vex. So vex is Houdini's own programming language that they wrote it on C++. It's basically C based. So if you know C++, C# somehow, it's really easy to use, but they have their own libraries, so it's not exactly like that. But you can also use Python or other programming languages, but so far I didn't need that. So if you know Vex, you can do everything basically in Houdini. So let's write our first Vex expression, very simple one. So I'm gonna select the one points that have the blue value, like because we said it's a vector, right? So the blue value more than a certain amount of number. Okay. So let's type at C capital. It's really important. CD dot B. Okay. This means color blue. Okay. And then I want this bigger than, I don't know, like let's say 0.5. Okay. When you're using Vex expression inside group expression, you don't have to use semicolon. You can also do it, but you don't have to. Okay. So if I click outside, you will see I have selected all the points that have the attribute of being blue more than this amount. Maybe it's two. Let's go for 8, so it's less. So now if I go back to geometry spreadsheet, I'll see in the group node, for example, point number 4 is selected, and all of them are 0, but the group 1 is 1, right? And that's how it works. That's how we select things. Let's delete these points, for example. So in order to delete in Houdini, we use the node blast. Okay, blast. Let's connect blast to this. First, when you click, you'll see it all disappeared, right? Because Houdini now is working on all of the geometry. The blast is applying the deleting procedure on everything. You have to say, okay, what group do you want? We go here in the group option, and then we select group. Okay? And now you will see it deleted all the points that has the value of being blue more than 0.8. Okay? Very easy. That's how we select things based on the attributes. Let's this time create another attribute based on the position. So we will see we have these options over here that tells us the position of the point in Houdini. So this time I'm going to say at P, okay? P capital. Why it's not responding. P capital dot Y means all the positions of the Y direction. And remember, in Houdini, Y direction is towards up. It's not like Rhino, don't mistake. In Rhino it's in Z, in Houdini it's Y, like many other procedural modeling, like many others. So So like I will say, okay, py, if my py was more than 0, select it. Okay, and then of course I'm deleting the group 1, so it's deleting this. If I want the top part, I will say delete none selected. Okay, everyone's following so far? Cool. Okay, let's go make let's make it a bit more complicated. So in order to,
complex.
yeah. So in order to change the, let's say the density of this mesh, we have some options. First is just to increase the rows and columns, right? Of course, in this case, it's working because it has the parameters, but if you're bringing some other uh, geometry from Rhino, for example, definitely you don't have this option. So you want to say, okay, how can I increase the mesh density? There are some options. First is the subdivide, that you can tell, of course, from the name, that is working with the subdivision algorithms like Clark. And the other one that we're going to use is remesh. We're going to use this a lot. So remesh has two options. We can go for fixed length. So in this case, I'm telling Houdini, and as you can see, it's changing the topology, right, between the points. So it's completely changing the topology and the behavior of the points. So I will say, okay, if I will go for 0.1, right, all the edge lenses will be more or less the same, 0.1. If I go for adaptive, it's working with the edges of the mesh. So it works better with the open meshes. And also you can tweak it later. So we're going to use this adaptive later also. It's very, very useful. It works with like the, how do you call it? The mesh machine of Fun Group, but of course, like 10 times faster. So I will go for the fixed length. And you will see on top, it's not randomized yet. So you can just increase the iteration in this case, or you just don't have to. Okay. So I have this somehow dense mesh. I would go for something like 0.5 in this case. So yeah, now it's better. Okay. So let's drop down our first point VOP. Okay, I'm gonna apply a noise value to randomize the positions of this mesh without being exploded. Okay. So okay, let's create a point plot first. Point VOP. What is point VOP? Point VOP is basically a VEX compiler with nodes. So whenever you feel like lazy, like me, to just write VEX, you will use point VOP. So whenever we use point VOP and then we select it, you will see there is no option here, right? That's why you have to go inside it. So you double click, go inside point VOP. Okay? So you'll see all types of attributes that this geometry has or doesn't have sometimes. And then the outputs. But it doesn't mean that we can't import or export something that it's not between this list, okay? But let's first work with these ones. In this point VOP, if you press tab, you will see now all these options are also different. So it's not like the geo node. These ones are only prepared to use in the VOP. And basically, they are all the VEX library converted to nodes, okay? So, okay, let's drop down in noise. If you just type noise, you will see so many type of noise. In this case, I'm gonna use anti-analyzed noise. You'll see so many options over here. but the most important is the position. So P, as I said, stands for the position, right? So we will go from position to position. And then after the noise, we have the new positions, right? So I'll say, okay, it won't work because now we have like crazy amount of noise, okay? So that's why we're gonna add these values together. So let's drop down in add node, and drop input the noise, and then the previous position that we had in here. And then the sum goes to the position, okay? Now, if you go to parameters of the noise, you will see these options. If I want to change it, each time I have to go inside it and then click on this and then change it. What other option that we have is to promote it. But first, let's say, okay, since it's a torus, it's 3D, I'm going to say 3D input, 3D noise, first of all. You will see it's already changing, okay? Then I will say the 3D frequency, I don't want to change it here. I want to change it from my geometry. So let's say we click on this gear node over here, the gear node, and then promote parameter.
Maybe we ask questions before we do this, if everyone is following.
Yeah, everything. Anyone has question?
Everything good? Awesome. Great. Yeah, go.
So guys, the gear icon over here, promote parameter. Also, I would say in this case, amplitude, the roughness, let's just keep it like this. Okay, we don't have to change it. And these are, in this case, we only have Perlin and Simplex, but in the other noises, I'll show you later that we have like so many options for the noises. Let's go back here. And now if you go back here, you will see the frequency, okay? And of course, it's a vector, so it has 3 values. But it's a bit hard to change them like this, like each time. So you can just press your middle mouse button, okay? Press it, and then if you go left or right, you can change all of them once together, right? You'll see it. Amplitude, let's just keep it like something like this amount. If your mesh is not, you will see it's not smooth enough. It's because your mesh is, the target range of your mesh is not small enough. So let's say if I go for even something denser, it takes a bit of time, of course, but then this will be super smooth. Cool. And now let's see, what is this offset? Of course, it's the offset of this noise inside this geometry. So if we change it, for example, I'm going to change it in, you'll see how it's working, right? Well, let's say you want to animate this. So you want to just press play and see how it works with the offset. Okay, in order to do that, Houdini before Vex, or actually at the same time, had another language called EtchScript. Sometimes we're going to use that for the simple ones. So in this case, we're going to use EtchScript also. So you just type $F. This means the frame number that we're in. So as you can see here, like we're in frame 1, okay? If we go to frame 144, this will be 144, okay? So this is a really big number. So I'm gonna divide this by 100 and see what happens. Now so $F divided by 100 in the offset. If we press play now, maybe it's a bit small, let's go for big. If you press play now, you will see it's animating based on this number, right? Everyone following?
How did you get the frequency and the offset part?
Yeah, so as I said, if you go to the analyze, anti-analyze nodes, you will see options over here, but you can just left click on this gear option and then promote the parameter, then you can see it in your point VOP canvas.
Okay, thank you.
So this is how we work with the point VOPs, okay, very basic. Now let's talk about masking options, or let's say attraction points, or these fall off options that we're going to work with. Okay, so let's say I don't want this noise applied on everywhere, but maybe somewhere around here. Okay, not everywhere. So how can we do this? And it's really important to know it in Houdini, the masking option. So in order to do that, we always need an attraction point or attraction curve or attraction geometry, doesn't matter, okay? We need an attractor. So in this case, I'm just gonna bring a point. In order to do that, I'll type add, okay? Add means the point. So it's not like Rhino that you can have a point option and then just drop a point. In these things, Houdini is a bit primitive, I would say. What happens? Wait. So let's drop down a add node. Of course, you won't see it because it's very small, but if you display point, still you won't see it. But if you, because we didn't create the point first, sorry. We have to click on this first, and then we have a point. Okay, so in add parameter, we have to check this, and then we have our point. And if you check your geometry spreadsheet, we will have a point in 0, 0, 0. Well, I don't want it in 0, 0, 0. I just want it to be a bit higher, okay? Well, let's talk about this pink option that I said. This pink one, it's called template, and if you just click on it, you will see the mesh wires of the geometry. So sometimes you want to see a couple of things together, okay? So if you press on this one, it will only show you this. But if it's on the pink one, it's always open, but in a wireframe shading. So now I can see the position of my point towards this one, towards this torus, okay? Yeah, let's go a bit right, maybe in the X direction. Cool. Yeah, it's a good attractor, I would say. All right. The next thing that we're gonna do is to create attribute for this point and to create attribute for the other point, and then blend these two attributes together. These attributes should be the same, and that's how it works. It can be anything, okay? So in this case, I'm gonna use the color attribute, okay? So I'm gonna assign a color to this node, to this point. Let's say red, for example. So now, of course, you won't see it because it's a point, but you see it's a bit red. And then we have this torus that we remeshed already. I'm gonna use the same thing, okay? But this time, I'm gonna say this color is white. It's already on white. And I made sure that my color class is on points, right? So now we use attributes transfer. Attributes transfer. This is how we blend two attributes from two different geometries together. Okay, so let's see what its requirement. The required one is the geometry to transfer attributes to. So this is our plate and this is our attractor. Okay. If you click on it, you will see everything became red, right? It already understood that we're working with CD, okay? But sometimes it doesn't understand. So you have to type CD in points. And of course, we don't want to transfer the attributes on the primitive, so we uncheck this. So points, CD, and then we want to say, okay, what is the amplification of the transfer? So we go to the conditions, and from here you don't have to change the kernel values and the element mode. You only need the distance threshold. So the distance threshold, let's say we go for 1 to see if it works. Yeah, it's working. And also to blend it a bit, we can increase this. And now we have the blend option. Okay. So how can I use this? It's only a color, right? So if I drop down another point, well, actually, in this case, let's say these are black. These are black. Yeah, because then I can use the color being 0. It's easier. Yeah. Let's go for color black. So let's drop down a point pop again. In this point pop, always make sure that you hit the render so you can see it and then go inside it, because that could be confusing. You change something here and then you will see it's not changing there. Am I selecting something else? Yeah, let's just get rid of this. So in here, let's this time create another type of noise. The noise is the same. I'm just going to use another method. So we're going to create a anti-analyze noise, okay? As before, the position goes to the position. But this time, as you remember, amplification is like a number that is, of course, it's like multiplied by this vector. So if it's 0, it doesn't work, right? And if we use CD as the amplification of this one, we make sure that, because CD black is 0, right? In some parts, we have the 0 value, the 0 attribute of color. So if we multiply CD on the vector, it won't happen here. And that's how we mask our noise. Okay, well, the other time we use the add noise, this time let's append a displace alarmed normal. So it will displace the mesh along its normal, okay? So we know the normals are here. So this goes to this. And the position of the point also. And it's asking for an amount. If I go for constant, let's say, if I go for constant value and displace point to the new position, oops. You will see how it's working. But of course, in this case, we're going to use a noise as an amount. Sorry. So noise goes to the amount. Okay. And now you will see, if you go back, you will see this torus is masked by another point, by the attribute of the color. Okay. And that's how we mask things. So everyone understood it. Later you can just change the color once more and I will make it blue. Whatever. Now everything's set back to normal. Okay. So question so far? Nothing? Everything's good? Cool. Control S every time. I'm gonna just.
Sorry, Adib. Hi. Adib.
Yes, I'm listening to you.
Sorry. Just a question. Is it possible on Houdini make the visual group like Grasshopper to make order in the script tab?
I didn't understand the question.
And then, sorry, to visualize the different step on the script, the group of grasshopper. When you select your operators and you can assign one color, for example.
So there is so much noise here, I can understand. So you want to visualize the group selection on the scene view? That's what you mean?
You're referring to some sort of like a custom preview, similar to custom preview in Rhino, in Grasshopper, or?
No, not custom preview. In the canvas, I can organize all the different to organize my script.
Like group though.
Yeah.
I never did that, but yes, there is an option. I mean, I've seen some, I don't remember what was it actually, but yes, you can do it. You can go.
Okay, well, we will see.
Yeah, but I never did that, so I don't know actually.
Yeah.
Yeah, but you can do it, of course, yes. So, okay, let's continue with something actually more complex, as soon as it. Okay, let's drop down. Let's drop down a test geometry here because we don't have any complex mesh. So if you just type test, you'll see all these test geometries that they have material, they have vertices, they have all the attributes that you want. So we always actually go for the rubber toy because it's super fun. So you will see this rubber toy over here. Okay. I'm gonna create the shortest path effect inside this geometry. Okay. So the first thing that we want is the points that we're gonna connect the structures together. So we want points from volume, and that's just type it point from volume. Okay. Let's see what it is. So you will see this grid of point, 3D grid of point inside this volume now. And of course you can jitter the seed so you can have randomized numbers, points, sorry. But in this case, I want to keep it like that, but maybe a bit more density. So for the point separation, I'm changing it to 0.5. Okay, so now I have more points inside this. Okay. So in order to use the shortest path, find the shortest path, what is asking from me is start points and the end points. Okay, so I have to give it the start points and the end points at first. And also it needs a surface to apply this effect on it. Okay, so we have to create a start point, end point, and of course the structure. So first, let's drop down a group. We want only, in this case, we only want one group, 1 point as the starter. So I'm just gonna go towards these millions of numbers and just randomly pick 500, no, sorry, 5,385. 5,385. I'm just picking something in the middle of this laboratory, okay? So don't ask me why is that. But you see, I made a mistake because the group type is on primitives. It should be on points, okay? Now if you just see, like we have some 1 point over here. I'm gonna name this group start. It's very important. The names of the group are really important. So guys, we have 2 names, okay? This one is not important. This can be anything, okay? The group name here, this one is important, okay? Now we have to say, okay, what are the endpoints? In this case, we'll say we want group by range this time, so not the normal group. So we can just select, it works like call pattern in grasshopper. So let's drop down a group range and hit select. And in here, let's remember we have the group time to be points. Of course, everything is selected, but in the range filter over here, I'm gonna say, give me 1 out of each 5, right? So if you go for the call pattern, it's like false, 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 true, false, 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 true, right? So I have selected these ones. Now I have to create a node between them, like the, let's say, a structure between them. So that's why we're gonna use connect adjacent pieces. Connect adjacent pieces, okay? I would recommend you always, before you connect this to this, change first to adjacent point and the number something small like 8. Because in this case, nothing happens, but if you have a really big geometry and it's on 100 and you connect it, it will crash. So first, the connection type, it's between adjacent points, of course, because now we only have points. And the max search point on 8. So I will select this to this, and then I will hit the play, and then you will see this dense structure of lines inside my laboratory. Of course, this is the search radius, so if you change it, you will have options, but since it's dense and it's maximum 8, you will see the difference with the search radius, but you know how it works. So this is the structure that I have, and this is the start and end. That's why I'm gonna merge these two groups together so I can put it in one node over here. So drop down a merge node, first and second. And if you click on this, you will see the name of the groups. Sorry, oh, sorry, I didn't name this end. Start, end, okay? So, okay. This is asking us for a surface geometry. Of course, we don't have surfaces, but we have primitives, okay? So these are the primitives that we have, and just we do it. And then this one is the merge option that contains two groups, okay? If we go to the find shortest path to the parameters, nothing's happening because we have to say which group, okay? I'll say start and end. Still nothing's happening. To the output path, we have to say from each start to each end, okay? Then you'll see it. So from each start to each end, of course, it makes sense, right? We want to start towards all of them. Since we have one start, so it's just from one start to each end. But you can have multiple starts also, okay? So we have this shortest path effect over here. That's quite useful sometimes, but I would say it's not 3D printable with FDM, but it's just cool to know, okay? So I'm gonna just animate this one also for you so you can understand it better. In order to do that, first I'm gonna fuse them together. So I play tab and hit fuse. Okay, what, oops, oh, sorry. So what is this fuse does? So if you go to the shortest path, you will see, I'll go back here and scroll down, you will see we have 26,000 points. And if I hit the fuse, I'll see, and I'll click on it, I'll see I only have 3,000 now. So it's definitely better for the computing without changing the geometry. And why is that? So fuse will merge the points that are too close to each other or on top of each other or are duplicated, okay? So that's what fuse do. It's kind of like a mixture between join and also delete duplicate points in Rhino, okay? It's basically fusing two points or primitive together. So after that, I'm gonna just drop down a carve node. And in this carve node, I'm gonna click on it. And let's go for the second U because it's line, so it doesn't matter if it's, we only need what U or V. So if I change this, you will see how it's changing. So let's create a frame-based simulation. So we say, okay, as I said, $F divided by 100 because this one works fast. So let's go for divided by 500. And now if we hit the play, you'll see it's animating these wires over here. But you will see some degenerate primitives also. So after that, you can bind a clean. And if you see, there is no points inside it anymore. Those small blue points that you have, it's because of the UV of the geometry. Okay, that's how it works. But sometimes you want them smooth. So let's say we want to imitate the vein, the structure of the body, right? So that's how we use smooth. So after fuse, I have smoothened them. You will see how it works now. And then carve it again. If you smoothen them before the fuse, of course you will have a very more complex geometry. Okay. So before I go to the next one, let's ask some questions. Let's hear some questions, right?
Can I answer the question of Diego?
So, oh yeah. Oh, I didn't see this. No.
So do you see my screen?
No.
Yeah.
I'm sorry.
Sorry.
So there is this option, create network box that you can bring and put different nodes inside it.
Okay.
Or if you're familiar with the so this is one option to organize, create network box. And if you're familiar with the concept of cluster in Grasshopper, if you press Shift C, basically cluster all the components into one, and then if you go inside, this would be a kind of a cluster of objects together. So I think with these two methods, we can organize our.
As Yorka is saying, also we can just type Shift O and this is grouping them now. We can
Thank you so much.
So Shift O.
Shift what?
Shift O. Yeah, I didn't know that.
Yeah. Shift O is a shortcut for the box.
Yeah.
Yeah, nice. Okay.
Okay.
Let me
No more question. If there is no more question, I'll go to the next one. Maybe a 3-4 minutes break or continue.
Maybe like it's now Central Europe time is like 7 minutes. 7 minutes break. We start.
Yeah.
15.
So we start in 7 minutes. I mean, you can just keep the video open.
Yeah.
So I'm just
1:15 here and probably 3:15 GMT.
all right. Yeah, in 7 minutes. Cool.
Hi, I have a questions.
Yeah, maybe I
Yeah.
can.
Right now the geometry I've shown, I'm still displaying all the number informations of the different surface. How can I stop displaying that numbers?
There again then. So in here, are you seeing my screen?
Yes, I can see.
So do you see this bar? So if you scroll down, there are so many options over here that displays the numbers. So in this case, it's displaying the primitive number,
Oh,
or you
okay,
can,
I see.
display the.
Yeah.
That's it.
Yeah. I lost that information before. So
Okay.
yeah, thank you.
Sure. So I'm just gonna go for a moment and come back.
So should we continue? Good to go. Yeah. Okay.
So, okay, guys. So, Igor, do you hear me? You had a question? Igor, you there? Anyway, okay, guys. So, no. So I just opened another Houdini, and then you will see it's on default. So I will go back, and then I'll choose the high side once more, and then it looks the same. Okay. So let's go to the OBJ again. So don't work in here. Go to the OBJ. Let's drop down a geometry again. And if Igor was here, he did a mistake. As I said, after dropping down the geometry, guys, make sure you have to go inside it, okay? If it's a very common mistake at the first, because if you try to work in here, you won't see anything that I showed you, right? Because we are in the OBJ accounts, we're still not in the geometry. So we have to go inside of the geometry, and then we have all of the, okay, Igor? Got it? Cool. I have to look top because you are on top of me. Later we will show you how this is working. Yeah. So, okay. Let's drop down a file mode this time. So what does this file mode? Whenever we want to read files from our hard drive or write files and export files from Houdini to somewhere else, we use this file mode over here, okay? So in this case, I'll just hit P so I can see the parameters. I want to read files, right? And let's go bring down the, you have the files of the Balerians, right? Just pick one of the OBJs from them. So I will go pick that.
Maybe we share the folder once more just to...
Or maybe just the OBJ number 5, I will drop it in the, let me see if I have it here, and then I will drop it in the WhatsApp group. So everyone will have it now. Maybe sometimes hard to find it. Guys, you have the OBJ elements coming now. Okay, let's just wait a bit so you can all bring it on. And then of course I can't see it because the file is too big. And that's a real important thing in Houdini, that you work with the right scale. So I'm always working in the millimeter, but the object is not in the millimeter. So I have to transform it first. So the transform node, as is obvious, is transforming, right? So I can move it or I can scale it. So I'm going to use the scale 0.01. Then I can see it here. Why do you see these things? Because the normals of mine is on. So I'm just going to get rid of the display of the normals. Okay. Now you will see this ballerina over here that we're going to, I'm trying to create this image that we had. Okay. Do you remember this? I'm just trying to create this now. So first of all, let's create this very simple wireframe of this ballerina. So everyone could load the object file. Should I continue? Because I want you to be at the same level with me. So I'm gonna assume that you all have it. Okay, let's drop down a scatter node. It works like populate geometry in Grasshopper, so it scatters points on these objects. Okay. In this case, let's keep it for no, let's go higher. So if you want to scatter more points on here, all you have to do is to change this force total count. I'm gonna go to 500 in this case. Okay.
Excuse me, Adi, how you open file number 5?
Okay, so from this file, okay, you just reference it from here from whenever you download it, okay, and then you hit the accept, and then you'll have it, because now I'm reading files. You got it? Then I transformed it and scaled it to 0.01. You have it? From file, from the geometry file, just click on this so you can select it. You have to click on this one. Okay. Then I will scatter 5,000 points on this ballerina. And then I'm gonna say, okay, connect the adjacent pieces, the one that we used before. Okay, as I said, I always make sure that it's not too much. So I will go for this time I will go for 3, maybe even 2, I will see later. Then I will connect them. Maybe I'll go more to 5, so I have the better wireframe. Yeah, oh, it looks better. That looks better. Now let's just drop down a color node so we make sure that it's red. Okay, so you have the wireframe of this ballerina. Very easy. Okay, now we're gonna use curl noises to create a vector field on this body, but of course we're not gonna apply it on all of the parts of the body. So I'm just gonna manually select the part. I'm gonna manually select the part, okay? So I'm gonna use this transform again. After this, I'm gonna blast something. If you go to the blast, of course, nothing's here. But what you can do is to first change these to primitives and then hit the space. It's not. Is it working? Give me a moment. So first of all, you have to check this and then select it in this case. Okay. So let me tell you what I did. So I created the blast. I put it on primitives. I checked the delete non-selected in this case. Okay. and then you want to select these primitives manually. You come here, you select this pointer, okay? If you want to perform, you won't change. So you hit the space so you can change, okay? Let's just, I'm gonna use the rest of it, okay? So because I'm gonna say delete none, sorry, delete the selected ones. So I'm gonna say, give me, let's just get rid of these. I want to have something over here. Maybe I don't want this part. We're literally manually selecting the primitives, right? Maybe a bit on the legs. Yeah, maybe even a bit on the hand and the neck. So if you hold shift, you can add. Yeah, I guess for our purpose, now it's fine. And after that, you will press the enter in here. And it's all gone. What happened? Wait, I have to do it again. That's really bad. Okay, now. So why isn't it showing me? Okay, now it's working. Delete the non-selected, and I will clean this afterwards. Why it's not working? We have to see the groups over here, the numbers. That's what I'm doing. Sorry guys, I don't know why it's not. Let me just test a bit. Just I don't know why it wasn't working like that. So before you blast it, you can also just use the transform, go here, and then select it from here. So I'm gonna select it from here before the blast. Usually works like that, but I might doing something wrong there. So let's just select once more. Maybe this is too much. A bit on the neck, a bit on the back. So we make sure we have this three-dimensional surface to work with. Not bad. Not bad for now. Okay, let's just hit delete after you select it, just hit delete. And then you will see this blast over here, but it will be after this, so we don't want that. So here is, and then delete not selected, and then we have it. So the lesson that we learned here is that Houdini is not a good program to use manual things, right? And we shouldn't do that. We always introduce attracting points, but in this case, just wanted to be faster and delete it manually. Didn't work. Okay, let's clean these. Because sometimes there are some degenerate.
There is a comment by Jorge, I guess. On Blast Note, I used the cursor icon next to the group.
I was trying to do the same. But yeah, you're right. That's what I wasn't doing. And hit enter. Anyway, yeah, so you can use this one. So let's say we have this option. Okay. We clean it because we don't want some options over here. Then I will remesh it because this mesh I would say is too dense. So mesh it again. But not like this. This is too much, maybe. Oops. Let's go for now. Let's go for let's drop another 0 over here, so we'll make sure. Yeah, now it's better. And now what we're gonna do is to create a curl noise in the point valve, but this time we're gonna use it for the velocity. And I'll tell you what is velocity. So drop down a point valve after remesh, display it, go inside it, and then this time use curl noise. Not the 2D version, but the 3D version, okay? What is asking us is the position, right? And the position at the end, the noise that we created will go to the velocity. What is the velocity? It's like when you have, when you're simulating fluid particles, they have velocity, right? They have speed, they have accelerations, and these vectors are influencing the velocity, okay? And that's how we're gonna tweak it. I will show you how we can change it in the volume later. So I would say let's also promote these parameters, the frequency, the amplitude, the offset, let's just keep it 0, 0, 0. The roughness, this one you don't need. So maybe these ones are enough, okay? Let's go back and we will see our options over here. And then after that, we're gonna write a bit of vex, okay? But not something crazy, so don't worry about it. In order to write vex in Houdini, we use attribute wrangle. Okay, attribute wrangle. Let's do it here. So you will see we have the velocity. We have the velocity of the points based on the curl noise, right? It's based on the curl noise. So what I'm gonna do is to project this vector velocity on the tangent of the mesh, okay? So let's do it. I'll say at v, not my caps lock is on, small v, okay? And then this equals to, so don't go for the capital V. The V minus or normals multiplied by the dot product V and semicolon. So what are we doing? Like, if you remember the dot product of two different vectors will give you only the length, right? So we multiply this by the n, the normal vector, which is perpendicular to the surface, to the face of the mesh. And then we're saying, okay, this, we have to subtract it from the V, so we will project it on a tangent, okay? But we have to make sure that we normalize it because it should be always between 0 and 1, because later we're going to use it in as the density. So I'll say normalize the new V. Okay. Does anyone have problem with that?
Can I suggest you copy paste the text in the group?
This text, yeah.
Yeah. Or maybe in the also Zoom group.
Oh, sorry. How can I do that? Where is the chat?
Hi, can I see what's going on the point VOP and once again?
Yes, inside the point therapy, I just added the curve noise and then I promoted these parameters.
And what's the parameters in curve noise? Okay, I was,
Yeah, the frequency, amplitude, and roughness I promoted so we can control it later.
Okay, and can you show that a little bit more? And I'm going to see what's going on.
I didn't change them yet, okay?
Okay. So it's
the parameters.
okay.
Later we're gonna tweak them.
Position. Okay.
Yeah.
The noise is connected to V, right?
No, the P to the position, and then the noise will go. Wait, it's my middlemost is really. So the noise will go to the V. Okay.
Okay. Thank you. I got it.
Yeah. So after we wrote this, we have the new value of the velocity. Okay. I'm gonna add. Let's just see the points first. So if you just drop an add node, and then let's say delete the geometry, check this option, delete geometry, but keep the points. So we will only see the points. Okay. I'm going to replicate a certain amount of points around these points also, so we will have more this curly vision. So use replicate or point replicate, sorry. In this point replicate, if you connect it, you will see this crazy fog of points, but don't worry about it. First of all, points per point will be, let's say, 3. And then after you go to the shape, just uniform scale it to 0.01. So you have replicated 3 points per each point of the geometry. Okay? Now we should introduce VDB for the first time in here. So in Houdini, the other class of the geometry that we're working with is the volumes, okay? These volumes over here. These are like the sparse volume. They have fog, they have voxels inside them. So basically they're completely scaled based. So you imagine mesh as something like SVG, like the vector-based programs are using, like you can scale them whatever you want. But this one is like pixels in Grasshopper, it's voxels. So the size really matters here, okay? But we have 2 types of volumes to work with. Actually, like volume is the parent of VDB. we have volumes, and also we have VDB, which is a library that many other softwares are using. So basically volume has a bounding box, but in VDB we always have an STF, let's say a surface, that will say if it's inside, something inside it, the density is 1 and everything outside is 0. And that's how it works. I don't want to make you confused, so just use VDB, and these are the voxels that we're gonna create volumes with, okay? So in order to create our first VDB, we need VDB from polygons, because we have these polygons over here. Also, it's better if you always change this and then connect it. It was a rookie mistake that I did, but because it's really small, it doesn't matter. So the voxel size, let's go for 0.0. Let's see, whenever it works. Something maybe, you won't see it, doesn't matter. Don't worry about it. Maybe something smaller, bigger, sorry. I think now it's better. So the very important thing in this is you can add the velocity. I mean, it has the velocity attributes inside it all the time. Okay, so if you go press this I over here, here we still don't have the velocity. So you have to add the velocity over here. So I just clicked on this button over here, surface attributes. Okay. And then select points.v, which means the value that we had already from our points, okay? And then name it v, small v, and then put this on displacement, velocity, and acceleration. Okay, I'll tell you once more. So after VDB, I changed the voxel size, and I used point v, and this velocity, acceleration. But the very important thing is we don't want to see the surface, because we're gonna advect these curves, okay? So just uncheck this, and we only want to see the density. Actually, we don't want to see the density anyway. We only want this V. So let's continue. We want to advect these points now. So we will use VDB advect points. There are two types. There are VDB advect and VDB advect points. We're gonna go for the point type. And let's see what it needs. First, it needs the points to advect. We go here, and then the next thing is the velocity of these points, and that's it, right? It's gonna drop down a plain note, but it's, of course, since it's advection, it should be completely time-based, right? So we can either go inside a solver, or we can change the time step over here. So we will just tweak it and say, okay, just give me the time step of 0.26. If it didn't happen, you just right click. When it's like this, when it's green, it means we have reference to another parameter. So you just right click on this and say delete channels. Okay, so you'll see it's black now. And I'm gonna say something like 0.25-ish. Okay, still doesn't happen. Then you have to put the substeps on 10 and output the streamlines. Now it's happening. It's a bit hard to see it, but I'll show you how to render it, and then you can see it. So, okay, so we have this. I really don't like some part of this blasting. Still, we have a really bad problem with the blasting. So I'm gonna just change it a bit. Yeah, better. Yeah, now it's better. So let's see what's happening. Let me just bring my So if I drop down a merge node, I just want to see what's happening here. So you will see this curve noise happening on this body. If we change the voxel size, it's following better, right? Okay, so let's continue. So we have this, and anyone has any questions so far? It's too bright. No questions? Let me just make it a bit less so you can see it.
Sorry, Adib, I have a question.
Yes.
Why we use the clean after the BDB object points?
When we use what, sorry?
The clean before the color and after the BDB object points.
Yeah, no, I used to use the clean because sometimes we have some degenerate particles or primitives. So I will use the clean just to get rid of those. It's like the clean mesh in Grasshopper that's you constantly have to use it.
Yeah. Okay, okay, thank you.
Just to avoid bugs. Yeah. So, okay. I just want to see it better. And maybe it's better if we scatter nodes. Points over here. So I can see them better. So after remesh, I'm gonna scatter some points just in order to see them better. Okay, scatter maybe 2000 here. And then we have the replicate, PDB main. Let's see why it's not working. Oh, we need polygons at the end. Okay, so no, we can't because I'm working with the polygons here. Maybe the remesh is too much. Let's go for something like fine. Not bad. Let's change the frequency. I would say let's go for bigger frequency so we have more curls. The roughness is good. So in case you can't see it, let's just let me show you how to render. Oh, let's put the render aside for now. Okay, let's continue from here. So we have these curls, and I want to say, okay, this is not multi-material yet, right? I'm gonna create some volumes in some places. Okay, there are so many options how to do it. Now I'm just gonna go for group range to select a couple of them and then add volumes to them. Okay, let's see it. Yeah, not bad. Okay, let's use a group range over here. Let's say, okay, from these primitives, give me 1 out of each 10. Let's also resample it here. By resampling, we are changing the number of control points. So we make sure it's smoother because I don't think it's smooth enough. Okay, now. Yeah, now it's better. You can see the curve ones. Okay, let's go for something like. So I want those ones to somehow blend to each other and dissolve towards each other. So for something, no, this is better. Yeah. So 1 out of 5 in my case, right? I don't know how you selected how you blasted your model. Okay. Now I'm gonna use blast once more to just get rid of the rest of the groups. I'm gonna put this on group 1. delete unselected. So you will see this shape over here. Maybe it's too much. Let's go 1 to 6. I'm saying it's too much because it's really hard to compute when you want to merge them together. So let's drop down a not that. Let's drop down a VDB from particles. Before changing it, before connecting it, let's always have small values here. So what it does, it's working with the points of the primitive and then assign a voxel to each point, okay? So common sense, we have to know that these points are somehow close to each other. So I'm gonna just drop down a resample node and resample it once more, this time with even smaller length. So let's say if we go for 0.1, it's like that, but if we go for 0.05, I wasn't checking it, maybe even more. I want them really close to each other. Yeah, now it's working. Now it's working. So let's change these ones. So by experience, I would say this point radius scale should be always twice as this one, okay? We're gonna go for something really small. So let's start with 0.01. So this will be 0.005. Okay, let's see how it goes. I would say it is still too much. So let's just append 0 to both of them. Definitely better, definitely. Cool. Yeah, this is what we want. Now these ones are all voxels, okay? It's not still mesh, it's BDB, remember that. So if I hit render, you won't see anything. You will just see a fog, okay? So let's drop down a BDB smooth here, so I can somehow dissolve them together. And I'm gonna use this one, not the STF one, BDB smooth. And it's gonna take a while. Didn't take. So you will see what smooth does is it's bridging the gap between the ones that are close to each other and just make further apart the ones that are far from each other. So that's why it looks like this. Now let's go for iteration 2 because this is too much. And see if that one's good enough. Maybe this is also too much because we have some of them that they're not dissolved to each other. Let's go for 3. I would say now this one's better. This one's somehow better. I mean, you have to constantly change things so you can get the best option out of it, right? So since we don't have time to do that, I'm just gonna leave it like this and continue, okay? So after that, this, as I said, this is not a mesh yet. This is still VDB. So in order to do that, we use VDB convert. And in VDB convert, we ask if you want to convert this VDB to volume or VDB or anything. So we go for polygons in this case and wait a bit. Okay. So now guys, this one is a mesh that you can just export it to Rhino or any other softwares. This is not 3D printable, remember that, but yeah, we're just learning this now, okay? So let me see what I have here. I'm gonna merge. Let me just, or let's just, we had a merge before, so I'm gonna use it. I'm gonna say, okay, let's merge these three together to see what's happening. The light is too much, you don't see anything yet, but when we go to the render, then I'm gonna show you how to render now. You will see them. Okay, let's just pick a camera. I'm just gonna show you how to render these things now. Okay, let's go to a cam. So anyone has any questions so far? I tried to be super slow, but yeah, sometimes. And no one? So you all have this shape now. Cool.
Sorry, what you mean?
Sorry?
Can we go back to the node that allow us to put the individual points together? I mean, closer?
Yeah. Which one? You mean the VDB smooth?
Yeah. So something over there in the, I mean, after in BDBs, you were explaining some nodes, I mean, some parameter in some node that allow you to put all the points together, I mean, closer each other.
No, I was just explaining what VDB smooth does. Like all the smoothing nodes in Houdini works like that. If they're close together, they will merge, and if they're far from each other, they will diverge. Okay, that was what I was saying. So what VDB smooth does is like that.
Okay, so if you want to have like a more continuous, like,
Exactly. So when you will go for less iterations, and you have some options here. The Gaussian one is the perfect one, but it's very dramatic. So if I, for example, let me just show you how the Gaussian one works. It's gonna take a lot of time, and it will all disappear. So you have to have really condensed VDBs so we can use. But at the end, it will give you a really smooth surface.
okay, thank you.
But I'm gonna use the mean value in this case. Yeah.
Thank you.
See, this is the Gaussian one. Okay, so I'm gonna merge them. Let's go and render something. Rendering in Houdini with mantra for this type of geometries that we don't have materials yet, it's super fast, okay? And it's super beautiful. So let's drop down a camera. So I'll go, so from here you will see this no cam, okay? I will hit the new camera and you have the camera. But you will see this camera came in the object canvas. So it's not inside my geometry. So everything rather than the object comes here, okay? So while I'm here, in the Houdini apprentice, of course, you can't go for the resolutions more than this, and you will have this trademark, but let's just deal with it. So if I go to camera one and you want to change it, just hit this lock button over here. You will see this lock camera. And if I change it now, my camera is also changing. Okay. Let's go over here and then unlock it. Okay, so I have my camera. I want light also. So bring down a environmental light. You see this here. Maybe in Houdini 18, the logo changed. I'm not sure because I'm using 17.5. In here, I'm gonna say the light intensity. Let's go for 2.8 for now. We can change it later. And the sky environment map, make sure that to enable the sky environment map, okay? It will be super light. All you have to do is to click on this, hide headlight only. It will be still light, okay? But we're still not ready for, or just let me show you what happens if we hit the render now. So if you go to the render view and then use in the ROP camera, use the object camera one, and then hit the render. Let's see what it gives us. I would say you all do the same also. So you'll see like it's something crazy, right? It's not working. Actually, I don't know why is it red. Ah, the red, yeah, of course. So you see it's all red, okay? Let's just stop it and go back to the scene view, go back to our geometry. And now I have to tell you, there is another very important attribute of points in Houdini called p-scale. So in Houdini, unless other programs or like let's say mathematics, point has a scale, but it doesn't mean that the point it has a scale. So always points, in order to shade it or render it or even work with it, we have to have a scale inside that value. So it has a factor. So in this case, if you don't use it, the factor is on 1. Okay, so we have to use a very, very smaller point scale in order to use the shaders or render it well. So that's what I'm gonna do. So I'm gonna use attribute angle over here, put it beside this, like the last thing that I'm gonna do, and just type at p-scale, p is small, remember, equals to something small like 0.0005. Yeah, I'm not sure. You have to check if it's working or not. And then hit semicolon and wait a bit. And you will see here I have this p-scale value on for some of them. And then I also need to do this for the curls, because the curls also are lines. So I'm gonna use a p-scale. So another. Oh, let's just Control C, Control V. You know what to do now. Okay. Now let's hit the merge again. For the mesh, you don't have to do that because it's already a mesh, right? Mesh is a scalable. Let's go to the render view and render again and see if our p-scale values are fine. Yeah, good. Yeah, good. I still don't see my. Yeah, okay. Fun fact. You will see it's black, right? These are the converted VDB ones that are black. Let me just stop the render. Sometimes when you merge something together, Houdini discalculates the normals, so we have to just use a normal point in order to recompute the normals. So we make sure that it's always in the right direction. Amen. Okay, so we hit the render again and see. Let me just, the color should be white. Let's see if it works. We can later change the color. You see, it's super fast, guys, because like my computer is like a very normal computer with 4 gigabytes of graphic card, 16 gigabytes of RAM. But Mantra is super fast in this case because we know that there is no mesh here. But since we're processing them as voxels, we can see real wires here. Okay. Let's wait a bit. So do you have any question when mine is rendering? Anything about the process or with the rendering itself?
So,
Oh, okay, let me just see the. Also, for some people, it's not working. Yeah, the split display problem is something we can tell. It's Houdini crashing. If it's crashing, you're doing something wrong. So you're using the wrong parameters. That's why I'm saying always change the parameters and make sure the parameters are right. I mean, of course, you can't make sure now, but by experience, you will make sure, and then connect them together. Then you won't have crashes. Yeah, we're gonna share the files later anyway. So okay, this is our geometry rendered. So I can just, if you want to save it, I mean, actually here we're not rendering a real render but since we're using apprentice version, I'm just telling you how to do it in this. But if you really want to render something, you have to go to the out and then create a montre and then change the values here. But since we don't want any high resolution renders, because these are only for tests, you can just right click and then save frame. Okay. And then from this save frame, I'm going to say JPEG. This time I'm just going to go on desktop. Remember, this one should be always JPEG. So if you change the name, for example, you won't have this JPG format, and at the end, it will be only a file. So remember, .jpeg, it's really important to have in your name. So if I save it over here, it's here. I can send it to you now. You will see this watermark. Okay, so you may say, okay, this is super different. Let me just tell you quickly what I did. Oh, okay. Yeah. So for example, in this case, it was the same process, okay? But I tweaked, first the blast wasn't a problem, so I blasted the right proportion that I wanted, the design value. And then I changed the frequency of the curl. And here I had also another tweak. So these wires have 3 different P scales. So you will see a little bit difference between the thickness of these curves, okay? And then also I waited a lot for them to use the Gaussian value for smoothing. So that's why we have a better, and I also had like 3 more lights for the render, but I also rendered this with Montre. Okay, if there is no question, we can go to the next one. I think it's after 2. Oh, so we have to have a break, sorry. Yeah, lunchtime. Gonna stop.
Here at least.
Huh?
Here at least.
Yeah, here at least.
Sorry, Adib.
Yeah, sure, tell me.
A question. Can you show after how we can export the file to be so we can import in Rhino or
Yes, yes. I'll show you.
other files, like for example OBJ or.
Yeah, sure. So, for example, if you want to send
Thank you.
this converted VDB, like the mesh that we had, to Rhino. Okay, for example, this one. I'm going to use a file mode first, and then connect this to this. You'll see some read files, but I'm going to use write files. Okay. The default format is BGO, is super fast, but BGO you can only use it in Houdini. So I'm going to use OBJ. So let's say I'm going to use it on desktop. Okay. Just save it on desktop. Wait a bit, because now it's exporting the BGO. Okay, now the file name will be test. remember you have to type obj. So if you just select something from here, it doesn't count because it's only showing you the. So if I just go for obj and then don't type .obj, it will be a file without any format. Okay, so we always need to say test obj. Maybe we'll wait a bit. It's going to be a really hard obj, I would say. So it's going to take a while. Cool. So if you go here, you will see the test object over here. But sometimes you want to export, where is it? Lines, for example. You can use DXF. You can use Ambelic. I would suggest the Ambelic one. So if you want to export the curves to Rhino, I would say go for DXF or Ambelic. Or if it's OBJ, if it's mesh, just go for OBJ. So any more question? You can go for a break if you don't have any question.
Cool.
Let me stop sharing.
Okay.
Mm-hmm. No question?
I think especially for those who were new to Houdini, this was a lot of information. Diego is saying very clear. Some other comments, Matteo lost because of the crash. Yeah, maybe we should have mentioned that like working with two screen is
Definitely
quite
better.
helpful. Maybe for the next sessions you try to provide that options. Yeah, this is also something new for us because the Zoom is quite tricky to work with. What else? I think we can have a break. We're gonna look into your presentations once more. I'm gonna mention that like I know now that you're missing the presentation of let me tell you like Vahid is missing and Lorenzo and Igor. Maybe you three, the rest are there. Maybe you three guys try to upload your presentations.
Upload my presentation.
Yeah.
Yeah.
So we can have a talk on the presentation during the break. And we're gonna meet each other in 1:45 minutes at 6 GMT. Yeah.
6 GMT, so it will be 4 CT.
Yeah, for Central Europe.
Okay.
4 GMT.
Okay, so 4. Okay.
See you guys.
See you guys.
And then make sure that we get the records ready.
Yeah, I will.
Cool. Okay.
Bye all.